That last construct that I showed you for conditional command execution, as I mentioned, was rather rudimentary. There is a much more powerful one available in the shell programming language. It's known as the if statement. You'll probably be familiar with this if you've ever programmed in any other language. Just about every programming language in the world supports the notion of an if statement. So as I said, it's much more powerful. It's also more readable. Well, it is for me anyway. This is what it looks like. We start by using the word if, then we put a command there. Now what happens at that point is that the command gets run. Immediately that the command completes, the shell looks at the exit status of that command and determines whether we should proceed into the next block of code or whether we should skip that block of code entirely. And if the exit status is a 0, meaning true if you like, then we proceed into the block of code, otherwise we don't. And if we do proceed into the block of code, then the very next word that the shell expects to see on the next line would be the word then. If you don't put the word then in, your shell will give you an error message. Then next it will execute those series of commands, and there must be at least one command, until finally we reach the phi. Phi, of course, being if spelt backwards. In other programming languages you might see this as end if or something like that. And the phi is put there so that the shell knows what point to jump down to if command 1 turned out to be false, or in other words, command 1 produced some kind of error. We would need, of course, to know where to skip down to. We would skip over commands 2 and 3 and so on down to the phi and then continue execution on from that point. So let's look at an example of that. We'll use diff as our example here. We'll run diff, we'll compare file 1 and file 2. Now the reason I'm redirecting the output there to /dev/null is I actually don't want to see the output of the diff command. I just want to know whether the two files are different or not. There's probably a command line option that I can specify to diff to say don't actually display the differences, just use the exit status to determine whether they're different or not, but I couldn't be bothered looking that up in the diff manual page. So I'll instead just redirect the output to /dev/null. Now if you recall, I mentioned before that if diff discovers that the both files are the same, then it will return an exit status of 0, which we can think of as meaning true, and so we will then of course proceed into the block of code. In other words, if the files are the same, then we go into the block of code. So if the files are the same, then we echo out the words the files are the same, then we remove one of them. I guess we don't need two of them if they're the same, and then we exit out of the program. So that's I guess a neat little example of the way you can use an if statement. Let's see something like that in operation. I'll just compare two files in this directory, names.dat and names.txt, and I will redirect the output to /dev/null because I actually don't want to see the output, and then I press enter and I get that little prompt that means you haven't finished your command yet, which is correct. I have not finished my if statement. Then I need the word then, and then I can say echo the files are the same, and then I can obviously remove names.txt, and that'll be enough. I don't need to exit. And phi. So now after I've typed in the word phi, the statement is indeed complete at that point, so it will run the statement at that point. So let's have a look and see what it actually does. It does nothing. That echo command did not happen, so I guess the rm command didn't happen either, which means of course that the files were not the same. Names.dat and names.txt were different. So I guess that's a fair proof that we now have the ability to control whether certain code gets executed or not. Okay, in the next module we will have a look at some extensions to the if statement that make it more powerful than you can see on the screen at the moment. In this module we examine the else clause, which is actually part of the if statement. We've seen that the if statement is actually a powerful language construct, Now that may be, but we still haven't seen a way to do the following two things. Firstly, we haven't discovered how to execute commands if a given command produces a non-zero exit status. The examples that I've shown you so far only execute the given code if a zero exit status is produced. We also want to find out a way to execute perhaps some other commands if the given condition that's specified is not met. In other words, we might want to do one set of code if the condition is met and another set of code if the condition is not met. Now, to this end, there is an addition to the if statement known as the else clause, and the else clause indeed offers us a solution to both of these problems. This is what the else does to the if statement. It's pretty much as you would expect if you've ever been a programmer. Just before the phi, you actually put the word else, and then you put a separate set of commands. So you'll either get the first set happen or you'll get the second set happen, depending on the value in command. So in other words, if command returns an exit status of 0, then you'll get the first set of commands, and if command produces an exit status that is non-zero, in other words false, you'll get what I've called another set of commands. Let's have a look at an example of that. It's pretty much an extension of the example that I showed you just a moment ago. If the files are the same, then echo out the files are the same and remove one of them. Else, in other words, the files are different, then echo out a word to that effect, and then also echo out please review the differences, and then we can obviously do the diff again, which will then this time display the differences. We didn't display the differences the first time, we redirected them to /dev/null. About the only thing you have to remember about all of this is that there has to be at least one command in the first half of the if statement and at least one in the second half, or in the else clause of the if statement. So if you think about it, we actually now have a way to execute a command if a given other command returns a non-zero exit status. Now what does that mean? Well, suppose that all I want to do is one particular block of code. In other words, it won't be like the previous example I showed you where we'll do one set of code if the condition is met and another set of code if the condition is not met. All I want to do is one block of code if the condition is not met, or in other words, if the command produces a non-zero exit status. Now let's have a look at how we might do that. Here we're testing to see whether file 1 exists or not, and in this particular code snippet we've decided that if the file does exist, then we really don't care. There's nothing that we want to do if the file does exist. We only want to do something if the file does not exist, and at that point we want to put out an error message and exit the program. So the way we go about that is we actually have a little do nothing command in the first half of the if statement. The do nothing command in Unix is just colon. Colon by itself is actually a Unix program. It does nothing at all. Pretty similar actually to the true and false programs. They do nothing at all as well. So if you like, we have an empty first half of the if statement, and we actually put what we want to do into the second half of the if statement, into the else clause. Now I'll give you some exercises and practice for all of this at the end of the chapter, but for now we're going to move on to the next module. There's one final addition to the if statement that we still need to look at, and that is what's known as the elif clause. Elif can be thought of as a bastardization of the words else and if. So what do we need them for? Well, sometimes we need to write a piece of conditional code in which there are more than two mutually exclusive options. So far we've only seen a maximum of 2 blocks of code that we can run depending on the value of a certain command. Well, we may want to write a piece of code in which there are 3 choices or 4 choices or 25 choices. Let's have a look at what that might look like. It looks like this. We say if command 1, then we do a particular set of commands from command 1. Next, instead of the word else or instead of the word phi, we put elif, which means else if. So in other words, it will only run if the first command produced a error or a false condition, And at that point we'll run command 2, which will itself produce a true or false value. And if that's true, then we run command set 2, otherwise we run command set 3. Notice that there is the word then immediately after the elif statement, just like there's the word then under the if statement. So that gives us 3 possible conditional code blocks. Here's an example of that. Now, in this particular block of code, I want to create a file that contains a list of all the users that are currently logged into the system, but I don't want to do that if the file already exists. So the very first thing I do is I check whether the file already exists, and if it does, then I put out an error message saying, sorry, the file exists. Now if that fails, in other words, if the ls produces some kind of error message, then we are okay to create the file. So then I run the who command and I send the output to the file in question. Notice that I'm using a variable name, $file, to represent the name of the file that I'm trying to manipulate. Obviously the variable called file must have been set somewhere before we get to this code. Now if the who command with its output being redirected to the file fails, there's only one possible way that could fail, and that is if we did not have permission to create the file, or perhaps the file was a invalid name. But if it succeeds, if we get back an exit status of 0, then we say okay, file contains the user list. Now if it fails, then we can say that we could not create it. So command 1 in this case is the ls of $file, and the command 2 in this case is the who greater than $file, giving us of course 3 separate code blocks. We're not restricted to just 3, of course. We can have as many elif clauses as we like on and on down the page, giving us as many code blocks as we want, but of course there can only be one else clause. Now I've just noticed a little error in the code that I'm showing you on the screen at the moment. Can you spot it? If you can't, maybe just pause the video at this point and see if you can find it. Well, yes it is. I need the word then underneath the line that begins with elif. So if we wanted several elif clauses, then we would have an elif then code block, elif then code block, elif then code block, and finally else code block, and then the phi. So it only took us 3 modules, but we finally got all the way through the if statement.